So since we finished up 9.2 with our special right triangles, we finished it up last week. We are going to be moving on to what? Chapter 9.4, yes? That's logical, right? Actually, not 9.4, 9.5 is what we're going to be looking at, and that's sine and cosine. Sine, cosine, and tangent really are the three functions that we have, trigonometric functions. Now, those are the three that we're going to mainly look at. We're going to look at them in their inverses eventually, because we need both of them to solve for missing sides and angles. Now, we're not going to get into all of the trigonometric functions that we could possibly cover, because we won't deal with the kind of secant, cosecant, and cotangent, which are similar to sine, cosine, and tangent. They're just 1 over. And we won't get into any of those there. We also won't cover hyperbolic, sine, cosine, and tangent, secant, cosecant, and cotangent. And that's talking about when the sides of a triangle aren't straight lines, they're curved. But we won't get into any of that. We're just mainly going to look at sine, cosine, and tangent. So there's more to it than just what we cover. Now, I did include these graphs here for y'all to be able to see. Now, if you notice something, what is happening to the values of sine, cosine, and tangent as they go across this whole graph here? They're repeating, aren't they? Because I have here and here are going to have the same values. It's going to repeat. The values of sine, cosine, and tangent, they repeat. These are called cyclical functions. They repeat. The values repeat. And let's see if I can remember how to spell C-Y-C. Yep, L-I-C. Cyclic. These are cyclic functions, cyclical functions. And now you know a word with 3 C's in it. Now, the main part of sine and cosine that we're going to be looking at is between 0 and 90 degrees, or pi over 2 if we're talking about radians. And that's the main spot that we're going to look at it for sine and cosine. Now, the values kind of flip, because if you notice at the start here, well, sine is at 0, cosine is at 1. And when they finish, sine's at 1 and cosine's at 0. Now, we're not going to be focused too much of finding sine of 0 degrees or sine of 90 or cosine of 0 or cosine of 90 degrees. We'll be mainly looking at the other angles. And that's kind of looking at the graphs, because I wanted at least so that you can see some of the pictures and what the values of sine as it progresses. Now, for us, this is really where we're starting. Sine of A. When we talk about any sine function in a right triangle, now this is really purely focused on right triangles. So we're starting out with this here is all based off of right triangles. Now, sine of A is equal to the length of the leg opposite angle A and over the hypotenuse. Cosine of A is the length adjacent to angle A over the hypotenuse. I'm going to get my highlighter out. And this right here is what's key. Sine is equal to opposite over hypotenuse, the opposite side length over the hypotenuse. Cosine of A is equal to the adjacent side over the hypotenuse. So when we talk about the opposite side, it's the side that's the farthest away from it. Adjacent is going to be right next to it. Another way we can think of this is sine of theta is equal to opposite over the hypotenuse. Cosine of theta is equal to adjacent over the hypotenuse. And theta, this 0 with a line through it, not all the way through it, but kind of in the middle, is called theta. We use the Greek letters, theta, for angles. So in mathematics and higher degree mathematics, whenever you see alpha, theta, beta, gamma, we're talking about angles. They're used purely for angle measurements. Now, when we have sine of an angle, it's equal to the opposite side length over the hypotenuse. So in any triangle, A, B, C. So if I'm talking about this angle A, well, this side length over here would be opposite, and this side length would be adjacent. Because the one side length is farther away, it would be opposite. And this side length here is adjacent because it's right next to it. Okay, I'm going to erase these here. Now, say we're talking about angle B. Well, now this side is opposite, and this side here is adjacent, because adjacent is going to be right next to it. It's going to be part of that angle. Opposite is on the far side. Now, the side opposite 90 degrees is always going to be the hypotenuse. Hypotenuse is the longest side. The longest side is always opposite the right angle. Questions on this here so far? We good with this here? Yes, yes. So really, opposite and adjacent is going to depend on what angle we're looking at, because it's going to change depending on the angle. Okay. Find sine of S, sine of R, cosine of S, and cosine of R, and write each S answer as a fraction and as a decimal, round to 4 places. So we'll start off with sine of S and sine of R first. Now, sine of S, well, sine is what over what? What goes on top? Opposite over hypotenuse. So I'm looking at S, so we're looking at this angle up here at the top, yes? So what is the opposite side length to angle S? Which would be what? 63, because that's the side farthest away from angle S, yes? Farthest away, it's opposite. Now, what would the hypotenuse be? Questions on this here? Questions on how we found this here? So it's opposite over the hypotenuse, okay? We good with that, yes? Is that all they wanted us to find? Or do they also want us? Round to 4 places. So how can we find the decimal to 4 places? Plug it in. Because we can do 63 divided by 65, and the calculator will give this to us as a decimal. And what came after the 2? 3, so we would round down. And that's it. Any questions on this so far? Okay. What about sine of R? So we're looking at this other angle over here. So what side is opposite angle R? Which would be? Over 65, which is the hypotenuse, yes? Well, now what do we do? Divide it. We can do 16 divided by 65, which will give us 0.246. So it would round up to 2462. Questions on this here? Will the value of sine ever be greater than 1? Why not? We could probably get 1, right? But what is this always over? It's opposite over the what? Hypotenuse is always the longest side. So That means if we're able to get a number greater than 1, it means the opposite side would have to be what? Greater than the, which won't happen because the hypotenuse is always the longest side. It'll always be the biggest number. So that means the bottom of this fraction is always going to be bigger than the numerator for sine, cosine, and for sine and cosine. Okay, well, I ran out of room. Now we need to find the same thing for cosine of s and cosine of r. Okay, what is cosine? Is what over what? Adjacent over the hypotenuse. Now, what's the adjacent side for angle S? Is 16. Because it's the side right next to it. Right next to that angle, it's adjacent. And the hypotenuse is? Which will give us 0.2462. Well, wait a minute. Did we have that one already? We already got that decimal once before, didn't we? What about R? Cosine of R. 63 over, because angle R, the side next to angle R, the adjacent side is that 63, yes? And the hypotenuse is still 65. And if we divide these, what do we get? 9 what? 9692. That's kind of interesting, isn't it? Because what happened, the value for sine of S and the value for cosine of R, they were the same, weren't they? And cosine of S and sine of R were the same. Wait a minute. If we look at this here, well, aren't those values the same? And it works out that these do match up at certain different angles. We will get the same value. And there's a way they line up. Okay, let's find these. Sine of S, sine of R, cosine of S, and cosine of R. So we can just start off with sine of S. Now, what would sine of S be? 4 over 5. Because when we look at angle S up here in the top corner, the opposite side would be 4, and the hypotenuse would be 5. And if we divide these, it would be 0.800. Because they asked it to 4 decimal places. Even though there's only 2, we add zeros to get it all the way up to 4. Now, sine of R. So we're looking at the other one. So the opposite side would be? And the hypotenuse would be? Which would be 0.6000. Any questions on this here? Okay, let's do it with cosine. So cosine of S would be adjacent over the hypotenuse. So the adjacent side would be, and the hypotenuse is still 5. Okay, well that's, how about cosine of R? And that is it. Questions on any of this here? Yep, might be helpful. Okay, we'll do the same thing again. So when we find sine, cosine of angles D and F, well, sine of angle D, well, that's going to be opposite over the hypotenuse. Well, the opposite side length would be 7/25. And if we divided those two here, we would get 0.28. Do we agree with that? Okay. So let's look at angle F. So angle F for sine, we need opposite over the hypotenuse. Well, the opposite side length is 24. The hypotenuse is 25. .96. Any questions on any of these here? Okay. Cosine of angle D. So cosine of angle D, cosine is adjacent over the hypotenuse. Well, the adjacent side would be 24. And while the hypotenuse is still 25, well, that gives us 0.96. And I would include those two extra zeros, especially on the homework, the online homework. Because if it asks for 4 decimal places, it's probably going to expect you to get 4 decimal places. And lastly, angle F. This 7/25, which will be our 0.2800. Any questions on any of this here so far? How do we feel about this here? Pretty good? Probably means the other shoe's about to drop, right? Okay. I think we're good with those there, yes? Because I don't think another example is going to make these any more clear than they already are. Are we good with these here? Yes. Sine and cosine of complementary angles. This is true for all values of sine and cosine. That sine of angle A is equal to cosine of 90 minus A is equal to cosine of B. So whatever angle A is, if we take that angle and subtract 90 from it, we would get the value of cosine. It also works out that sine or cosine of angle A is equal to sine of 90 minus whatever that angle is. So they have this relationship all the way through. And they have it written the other way, but the main thing is that sine of angle A is equal to cosine of 90 minus A. And cosine of A is equal to sine of 90 minus that angle. And this will always hold true. So what we're going to do here is real difficult, real challenging part. I want to write sine of 56 degrees in terms of cosine. Well, what do I know? I know that's, well, it might be helpful if I can actually write. I know that sine of angle A is equal to cosine of 90 minus that angle. Well, so they told us what? Sine of what? 56 is what we're given, yes? So what's angle A? just A. So in this here, so we have sine of 56. What's the value of A? It's 56, because this matches up, right? A is. So we'd have cosine of 90 minus what? What is 90 minus 56? Cosine of 34 degrees is going to be the same as sine of 56. Those are going to have the exact same value. Well, you don't have to take my word for it. So you have the calculator in front of you, yes? You know where you've seen the sine, cosine, and tangent buttons, yes? In the calculator, type sine and then 56 and see what it gives you. And it just keeps going, yes? Okay, now do cosine of 34 and see what it gives you. The exact same thing, isn't it? Yeah, and this works out every single time. But I can take the original angle, subtract it from 90, and that's what it will be for cosine, or vice versa. So what do you think of this here? So 0.829037573, yeah. I mean, they're the exact same number. I think I messed up on the writing it, but they are the same, yes? Yeah, this might be a little off. Because what should this decimal be? 8290. I don't know. Okay. So they are the exact same, yes? And that's what it is. And this formula works the way it does. Okay. So this time we want to write sine of 43 in terms of cosine. So again, we're going to be using this formula that sine of A is equal to cosine of 90 minus A. And we're starting off with sine of 43. So we're starting off with sine of 43. That's what they told us. Now sine of 43 is going to equal to what? Cosine of? Mm-hmm. 90 minus 43 would be 47. So our answer would be cosine of 47. That's all they're asking for. Questions on this here? Write cosine of 23 in terms of sine. Well, cosine of A is equal to sine of 90 minus A. What did they give us? They gave us cosine of 23. So for us here, it's going to equal sine of 90 minus 23. And that's our answer. I don't know why I heard 57. The 67 makes more sense. Questions on this here? We good with this here? So if I wanted to write cosine of 12 in terms of sine, well, we can go back to the formula and saying cosine of A is equal to sine of 90 minus that angle. So cosine of 12 is equal to sine of 90 minus 12, which tells us our answer would be sine of 78. We're really just taking 90 minus that angle and getting our answer. Any questions on any of this here? I think we're good with this here, yes? Because I don't think doing any more of these are going to make it any easier. And I think that's the end of the notes, isn't it? Because the last one is sine of 67. Yep. And that's it.